update, FC-1, which I just got out of the air. And again, this is an update again, because I've done this before. Now, what we're looking at here is an updated, oh, by the way, the presentation and the movie and the slides, I'll put on Dropbox and give you guys a key, or give a key, so that anybody can access the slides later. Because I think my friend in Australia, Lou, said he couldn't see the screen, so he asked for the presentation. But anyway, this is the block diagram of the rig. This is a very traditional single conversion rig, much more involved than a lot of the single board kits that are on the market today. Now, I've made some changes to it as I've been going along, naturally. I've had to add attenuators in some locations to decrease signal levels to the proper levels. Basically, comes through as SWR detector, go through the low pass filters, PA for receiving can bypass, and then we go up to the band pass filter, to the attenuator, RF amp, mixer, noise blanker, crystal filter, IF amp, color detector, and out through a DSP filter and the AF amp. Since the DDS VFO drives the mixer at 16 megahertz, and in transmit mode, it puts out 7 megahertz for 40 meters. So it's the boxes in light gray. I don't know if you can see it. The light gray boxes are the items that I have finished. To do the RF amp, the PA, and there's an amp driver here that I have yet to do. Other than that, it's pretty much complete. So I went over before the general mechanical arrangement. We'll see it a little bit later. It's not too big. It's only about, this big, this high, maybe this deep. So there's a lot of hardware that has to fit in to that small box. The other thing is that every one of these modules are individual modules. They are shielded boxes, and they all use SMA connectors with RG316 coax hooking them together. This is the receive module, whole thing. And I'll pass this around. Basically, this sits on the chassis. It sits on the top. There's a sub panel and the transmit sections below. RF comes in here, VFO, audio comes out here. And these are all the signal connections. But this is the entire thing. You can take it out, you can open it up, work on it, and the transmitter section below is very similar. All these interconnects I had to make myself. Crimping all the SMA connectors. It was quite a learning experience. You will notice that on the connectors, they're not at 90 degrees. Some of them are slightly angled. The reason is because it's so tight. You have to be in a big room to get the connector on. So, my only request is, don't drop it. As it's going around, please don't drop it. But all the little boxes, I had to make every one of them. Each one of them, they're all 1 millimeter PCB that were cut, soldered, and fabricated. And so there's little boards inside there. And here's a sample. This particular, this is the AGC detector, and it's, if we look in the back or on the bottom, This is the AGC detector. There's a separator in here, AGC on one side, and the detector is on the other side. And basically, I'm using two. Let's go back one. I don't want to go back one.
Receive section of the transceiver.
I'm using two AGC types. Got IF AGC. We also have audio AGC. In other words, I take audio and IF together and create the AGC system. It's not my design, it's a friend of mine in Australia, VK3AQZ. What basically does is the IF signal determines the rise time. The AF controls the hang time. So it's a combination of both AF and IF that runs it. And I will have to admit, it was rather hard to get everything in that little box. Anyway, the IF comes in here, it's amplified. This is the AF portion where it goes into the detector. This is the detector here. The detector is a balanced detector, very old, an LM1496 balanced detector. The chips are hard to get nowadays, but they're very big balanced detectors. They're very popular, my goodness, 30 years ago. So that's what it looks like inside. You'll see these are studs. These studs go, I think these are 17 millimeters, and they go through the board, and there's a second stud 5 millimeters underneath that's soldered to the box. And that's what holds the top on and the board into the module itself. This construction style is, as you've noticed, perforated board style, which is good for audio. Not so good for RF, but
good enough, right?
no, it's not.
It's not.
No, it's by the time you get up to the IF amp at 9 megahertz, you're in trouble. And I will show that to you. Okay, and when the IF amp itself, it's using a video chip, an 8603. It's an SMD. And we've got a tune circuit coming in, tap to adjust impedances. And we have bias settings, gain settings, and then the output. This is from the IF amp. This is where we take the AGC going into the IF AGC. And this guy goes to the detector. So that's basically what it looks like. I mean, it's not that complicated. The only thing is, this little guy is 8 pins and it's really small. I mean, SMD, it's really small. Now, when I built it originally, as you just were mentioning, is it good enough? I built it on a perf board. The 603 was mounted on a breakout board with pins, and which were plugged into this 8-pin socket. Well, looked good, except it's a very poor amplifier, but it was a really good oscillator. Just took off and went bananas. And I couldn't tame it. The biggest problem is that you have a very weak ground with this type of board system. It's just not good enough. So we scrapped it and I rebuilt it again. This time I went Manhattan style. Now here's the same breakout board, another one, that I took my Dremel tool against, and I cut the devil out of it. I just cut it down to the absolutely bare minimum. And it's glued to a complete copper board. Now, Manhattan style, does anybody have a question as to what that is?
What is it?
Okay.
What is Manhattan?
Manhattan style in New York,
Where it is, but
there's Manhattan. Manhattan's an island.
Right.
So Manhattan style is island style. There's there's another style they call dead bug, which everything is suspended in animation here above the board and it's just tacked in your place. It's good for prototyping, but not very sturdy. Now I've got a little tiny board here that I'm going to pass around, and you can see an example of Manhattan style. This is just a test board because I had some issues. You like that, huh? Yeah, it's good for RF. It's really good. Anyway, I have a aluminum nibbler, a nibbler that you just cuts slots or in square holes in aluminum. But it makes, if you cut PC board, it makes very nice little islands, and that's what you'll see. That those little islands are from my nibbler, and I just cut a bunch from a PC board, and then I attach the islands to the ground plane and solder the parts to that. And this was a good learning experience because the question is, how do you attach or what do you use to put the island on the PC board? And first thing I did was use epoxy. Epoxy was okay, except it took forever to dry. So you put down some islands and you have to wait for 2 hours for it to dry. So the next thing I tried was super glue. I thought, well, that's pretty good. Sticks to everything anyway. Super glue, I could just snap it off. And the next glue I tried was a gel super glue. It kind of has the consistency of epoxy. It's kind of a thick super glue. And I tried that. Dries fairly quickly, but it breaks also. This is super glue, but any type of lateral pressure, in other words, if you have the island and you push on a component, you can snap it up and it'll break. So that was really disappointing. And I'm back to using epoxy again. But as you can see, the ground plane is all over the entire board and the parts are tacked in there. And it can be very, very small. You can make it really small. So here's the entire IF. The board is this big, This particular end module is the IF. So this whole thing is inside here. So anyway, it second time worked. So it's good to go. Now, here comes trouble. Crystal filter. And this took some out-of-the-box thinking, I will tell you. The crystal filter is right here, I think. Right here. So a little bit smaller than the IF. And you can see how much has got to go in there. You've got an amplifier, the filter itself, which is all of this, and then you have a buffer. And impedance transformation coming out. All this has to go in that box. And there's no way it's going to fit on one board. So I had to do some thinking on this one. This is what it looks like. There's one board here, and there's the studs, and there's a stud over here. There's 5 millimeters. You can see one here, 5 millimeters high. This is the big stud, 17 some odd millimeters. It goes through the top, goes through this board, and screws into this board here. And on each corner, there's another 5 millimeter plastic spacer here and here. And the nut is soldered on the bottom, so I can take it off here and then take this board off. Now, the top board looks like this, with islands cut in. I don't know if anybody has ever done this before. There are drill sets, bits. They're called island cutters. And there are different diameters, and they will cut islands. I'll pass these around. You can take a look at these. They really should be used with the drill press because it's got a little bit in it. It cuts the island, and it has to really come down straight to make it clean. And I don't have a drill press. I had to do it by hand, so it's not really too good. But I did the best I could. But I had to have islands there because the crystals are mounted here. Anyway.
And holding the board also is, holding the board while you're drilling is also.
No, well, I just hold it on the drilling platform and drill down. Now, on the bottom board, this board here, on the underneath side, we have the amp and the buffer. And I only have 5 millimeters of clearance, so the transistors had to lay down. Everything was laid down, so it clears the 5 millimeters. Now, the crystals, these are HC6U shorties. I think these are 4 millimeters high. They're mounted on the second board facing down, so that legs come up this way. So here's the amp, here are the crystals, and here are the capacitors for the crystal filter. And it kind of is shaped like a V. Comes in here, goes to here, and comes back out here. To get the signal from the bottom to the top, I broke apart some connectors and just soldered them in. So there's one connector here, there's another connector here, which you just put the board in to get the signal. And this is where the stud goes. And then I put the shielding on. So here's the bottom board with its shielding. There's shielding separating the actual bodies of the crystals, and there's shielding about 80% to separate the capacitive components. I really wanted 100%, but there was too many blasted capacitors there. The trouble is, let me go back a little bit. Oops, I don't want to go back there. The values required for a 9 megahertz crystal filter, you just don't buy the capacitors. You usually have to take a pair and match them to get the value required. As a result, you come out, let's see, which one am I going here? You come out looking like this with all these parallel capacitors all over the place. Anyway, it fit in there, and it actually worked. Lo and behold. And that's the response curve of the crystal filter. And it's better than it really looks because this is about 1 to 2 millivolts RMS. I couldn't get below that just due to stray noise. I couldn't see. I mean, it should be much better, but this is just garbage noise. But what I'm really interested in is this curve at the top. And theoretically, it was 500 hertz filter, but it turned out it was 600 hertz, and the center frequency was 9.00432. And it doesn't look too bad for making it at home. Here's a bit of a quirk of this spreadsheet I'm using. Normally, these numbers should be down here. But if you enter negative numbers, use negative numbers in the spreadsheet, it puts the numbers at the top. So that's just a quirk of the software I was using. So I didn't do it intentionally to make anybody use it. So now we got a crystal filter working. And So you get the IF crystal filter. I'm gonna skip over the band or the noise blanker for now. That's the last on the list. Next is the mixer. Now the mixer also uses the LM1496. We have a balance control, gain control, and the RFN, and this VFO in. Tune circuit out. And this tune circuit gave me a lot of trouble, but I have a 15 decibel pad here because this particular device wants about 100 millivolt RMS carrier. And I had 250 millivolts available. So I had to put a 15 decibel pad in there to bring it down. I've got about 120 millivolts there now, so that's not too bad. These are trifilar wound toroids that were more difficult than I anticipated because the wire is relatively fine. Now, when I first made this, it didn't work. Zero. But 16 megahertz in here, 7 in here, and I got zip out there. I couldn't figure it out, and I just racked my brain. And the guy in Australia who originally did this circuit told me, he said, well, number one, he said, just put 9 megahertz in. See, it's basically working. If you put just 9 megahertz in with nothing here, you should have 9 megahertz out the rear end, and it should be tunable. And I didn't. Well, it turns out I used a different toroid than him. It's the same. He used a T50-2. It's a half inch, and I used a T37 because that's the only thing that would fit in there. The bigger toroid was just too big. And I think there's how many turns? 13 turns. But the smaller coil and the density of the coil is such that the inductance is much, much higher. So out of desperation, I took the LC stuff off and I put it on a Manhattan style board, and I put my grid dent meter on it and checked it. And it actually was resonating at about 7 megahertz, 6.5, 7 megahertz. But when it does that, these are differential outputs. When it does that, it's off frequency, therefore they appear as a short. That's why you don't have anything. So I redid the LC and rebuilt it. Well, I actually didn't rebuild it. I rebuilt this section here. This is the board, Manhattan Islands. And these little guys, it's one piece. I made it by just cutting it with a Dremel tool and doing that. Another good source of items are edge connectors from old memory boards that use the 10-inch centers, the wide centers. The newer ones are very, very small, but the older, really old memory boards have a good pitch, and you cut them with a Dremel tool, and you've got a nice string of items. But my photography is terrible. Again, this is what basically it looks like after it's completed. And we have, this doesn't show the pad yet. I don't know if I got another shot of that or not. There we go. See, it's in the box now, and these resistors here are for the carrier, and this is the 15 decibel pad. And this is the balance control, the gain control, RFN, and B+, and the power out. So you can actually see, I mean, the circuit is so complicated, but the Manhattan style, you can really pack it in. Look, there's lots of free space all around things, so that works out quite well. That works out quite well. So these are just, didn't remember whether or not I had showed these to you before or not. On the front end of the receiver, there's a bandpass filter that's used, and this is actually Hans's QRP Labs bandpass filter. And that's in another module base, the transmitter module base, which is underneath the receiver section. Receiver's on top, transmitter's another subplate on the bottom. And it's the antenna relay. So the transmit signal, basically, the receive signal goes this way and the transmit signal goes this way. So they both go through the bandpass filter. And I think, yeah, this is the bandpass filter response. So you can see at 7 megahertz, we're up on top. We've got a slight peak at about 7.3, but I wasn't too concerned about it. It's only a half a decibel. It's nothing to worry about, and I wasn't going to fool with it anymore. But it has a fair skirt on it. It's not too bad for an LC. These are millivolts. So now, the low-pass filter, it has to be able to withstand the power. So I built this one. I had originally a low-pass filter from Hans, but it was a little bit lightweight. So I rebuilt it using microcapacitors, 600-volt micas, and put extra shielding between the sections to get a better response. And this is on the bottom also, and this is its box it sits in. And these are the big cores, so I had to mount the board way low on the in the box itself. Here's the, no, it's not it. What happened here? Oops. I think I made a mistake. This is not the low-pass filter response. I don't know why this got in here. It breaks at about 7.5 megahertz and just slides down. So it's a fairly nice curve, again, for a seventh order filter. I don't know why I got that guy back in. Now, so that's about an update as to what's happening. Now, the last time I came here, I talked about Hans QCX transceiver. And I brought it in. For those who are unaware, Hans released a 5-watt QRP transceiver kit last October, as it released. And the LCDs with it and the controls, no case, so you have to use your own. And I, as usual, had to make some updates, my own. The big issue was that he's using very low noise op amps for the audio out, no special audio chip. So it has about a 40 ohm output impedance, and it's only good for earphones and the earbud type. In other words, like you buy for a Mac or an iPhone, these little white guys. That's it. There's no AGC in it, thus pain. And I'm in a lot of pain. If you got tuned to a signal and some guy with 100 watts comes on and it's close, it'll really hurt your ears. The receiver itself is exceptionally quiet. Exceptionally quiet. It's not like in my architecture. It's a standard RF amp detector, IF amp, etc. Hans uses what's called a quadrature detector, 4-phase detector, and he puts it into a set of op amps and they cancel the opposite sideband. But the whole thing is very, very quiet. Well, the bottom line is, and I noticed it when it was operated a few weeks ago at an event, people have a tendency to turn up the audio gain until they get a background noise that's similar to what they are accustomed to. And if you do that and a big signal comes on, you're going to be in for a super surprise because it'll blow your ears off. So what I did was, to make life easy, I added a magnetic mount speaker on the top. I added audio AGC, and I added a small audio amp. It's about 900 milliwatts. And Akizuki Dinky sells from about 500-600 yen for 900 milliwatt, 1.1 watt amps. The benefit is I've got the AGC, but I've also, the audio amp now is not 40 ohms, it's 8 ohms. It'll drive a speaker. It'll also allow you to use earphones. Monaural, whereas he had his set up for stereo, although it was being fed by the same signal. So it was a big benefit to me. There are a couple of issues. This is the little transceiver itself. I put it in a little box. It's got the AF gain, some of the function buttons, and the main tuning. And speaker, I ran across this one in Akihabara at the ham store. It's kind of a nice size and has the mute, 8 decibel mute. Also has the earphone connector here, and the output level here has already been reduced to match the speaker, so you don't get your ears blown off with a set of earphones. And when you buy it, it comes with a metallic plate and some double-sided super tape. And I just put it on the top of the rig, and this allows me to put the speaker on. I can actually pick up the whole rig just by picking up this. So the object was, it stays with the rig, it's easy to move around. You don't have to say, well, where's the speaker? Can I give it? Somebody have a set of headphones, et cetera. So now the AGC is an issue. There's no IF in the QCX, so you're going to have to use an audio AGC, an audio only. Now there are a number of circuits that do similar work. Basically, audio is taken from the original preamp, goes to a secondary amp, full bridge or a full wave rectifier, timing capacitor, and it drives this transistor, which in turn lights an LED. The LED illumination is shown against a, well, some people say it's what, a CDR or LDR, the light resistive. What is the resistance changes with the intensity of the light, and it will, for example, with no light against it, there's 50K of resistance here. Full brilliance, there's only 300 ohms. So you have a good sweep of resistance just by shining an LED on it. What basically is done normally, this line would be the original in the amp, or any QRP rig or whatever you want to use. Preamp into the volume control. Just break this, and you put in a 1.7K resistor, at least in my case, 1.7, and this comes through the light diode, or light resistance, to ground. So when this is illuminated, you're basically paralleling this resistance with the volume control. Now, a lot of these circuits, the timing is really screwed up. I mean, basically, I had to change a lot of the timing values here to suit CW, because a sideband would have a different timing on it. The hang times would be different, etc. And I eventually wound up using a 2.2 microfarad cap, and there's 4.7K in series to the base. And the timing works really good. I mean, there is a bit of sharpness on the leading edge of a CW signal, and basically because you're playing catch up here. You know, the signal is obviously going to appear here faster than the light can illuminate this. And the LDR has got a response time of about 15 milliseconds or so, maybe a bit more. The interesting thing is its wavelength that it's sensitive to is 540 nanometers. Now, various LED colors will have different wavelengths of light. And it turns out the orange, or the yellow bit rather, is 580, and that's what I used. So you can actually play with that a little bit. Then I put a current limiting pot here so that I can actually change the level at which it starts to operate. And it works really good. There is one issue. In Hans's transceiver, he has a transmit side tone, but he introduces a side tone up here in front. So when you're in transmit mode, the side tone is taking the same path, and it is a big signal, so it's being reduced naturally by the AGC. So if you turn it all the way up, you can hear it, but it's not too loud. So I normally use an external side tone anyway here, but this has helped immensely. This makes it a super pleasure to operate now, whereas before it was a constant struggle on the gain control and hoping that some big signal didn't come down on top of you. So actually, as I showed in a previous presentation, the box is not that much larger than the board. So the question was, how do I mount these things? Well, it's got 4 mounting posts, or studs, in the corners of the board that go into the bottom of the chassis. And what I did, I just put a threaded stud on top and put a PC board to become a holding place for the toys. This is the little audio amp, and this is the AGC. It's got a 5-volt regulator, audio amp, and the LED driver on it. Here's the resistor and the LED. And that's all there is to it. It's only about that big, a couple of centimeters. So it fits, and actually there's room for some extra toys too. Now, activity. Using this rig with this antenna, I had about 160 QSOs in 8 countries.
Good.
9 US states, 1 Canadian province. Now, here's the thing. A couple of weeks ago, there was an ARRL DX contest. I said, why not? But obviously, the ARRL DX, it's only US versus us. You have to, there's no, talking to other countries. It's all US stations. So, but I thought, well, give it a shot. So 5 watts, and this antenna had 27 QSOs, 9 states, 660 points, which isn't too shabby.
That's pretty good.
Yeah, surprised the devil out. I worked the entire Western United States. But obviously, the guys in the States are the big guns. I mean, these guys had 40-meter multiple Yagi antennas and were running kilowatts. They could probably hear me drop a mouse in Tokyo. But years ago, I used to be very envious of these big stations, and I always wanted one. But now I'm very thankful that they're there. Those guys can buy all the big antennas they want because they give me a shot at some international QSOs. But 8 countries, that isn't too shabby, and that includes Europe, Belarus.
Oh, you moved those?
Yeah. And still, there's a lot of open countries here in the Pacific area that shouldn't be that hard to work. Japan from Hokkaido to Kyushu is super simple with 5 watts. You don't need a 100-watt rig to work the entire Japan. And that's pretty good distance. But obviously, we're in the middle, so it isn't that far this way. But from Hokkaido all the way to Okinawa, there's no problem with 5 watts. Absolutely. And it's kind of interesting to be sitting there with this little tiny thing on the table and saying, this is a complete amateur station. And it, including the speaker, the box, and some of the miscellaneous parts, I would suspect I've got about maybe 10,000 yen in it. About that, that's all. So, yeah, granted, to make this is a pain in the rear. You have to make a square hole, and you had to make these holes and stuff. Not all people are up to it, but that was kind of a sidetrack from the
This is all in 40 meters?
40, all 40.
It's one band.
One band. Now, the thing is, with these, with this kit, you can order, when you order them, you tell them what band you want. So it's 80 meters, 40, 20, and 17. 15 meters is a little iffy, and there's nothing for 10. But got some guys that are in a forum, they're trying to move it down to what's way below the broadcast band.
Oh, the new one?
Yeah, there's something down there. Anyway, they're talking about trying to convert one. And of course, the obvious issue is, what on earth do you use for coils?
Yeah, you need a lot
You
of
need some serious inductance. But I mean, there's some really off the wall stuff. They're tearing apart IF transformers and doing all kinds of strange stuff to try and come up with putting one of these things on super low frequency. But you just tell them what you want when you order it. The instructions for it are 117 pages and full color. They're probably one of the best manuals I have ever seen, and that includes Heathkit. It is super manual, has all the instructions step by step, theory of operation, the how-to, what the functions, etc. are. At the end, there's a troubleshooting list. So if you get in trouble, he shows you what steps you should take to try, to resolve your problem.
This is a PK.
No, this is Hans.
This is Hans.
This is Hans' kit.
I see.
The VK fella, he's building actually a multiband transceiver. It's completed now, and he and I have been working together the past couple of years. Well, not working together. He's been mostly helping me. And he recently submitted a very large document with schematics and all to the WIA in Australia, which is a JERL equivalent for publication. They have a publication in WIA, something, AR, Amateur Radio AR magazine. It's like the QST or Japan does something similar. But anyway, so we're 2 years and counting.
Oh, you've been 2 years working on this?
2 years working on this now. Original schematics all back 2015, the latter part of 2015, 16 maybe. Yeah, but it's like I was telling a few fellows here earlier when we were downstairs, I'm still working full time, 40 hours a week. So I really don't have spare time to sit down and build all this stuff. So Saturdays and Sundays is about all I have. So it's a bit slow going. What's left now is the receiver RF amp and the transmitter PA. I had the PA, I have all the board and parts, it was a kit. This is going to be Manhattan style. And I've got some, the noise blanker, yeah, the noise blanker. If we were to open this up right now, the RF amp and the noise blanker consist of one wire, connector A to connector B. It's a jumper. The noise blankers are difficult, especially with the OTH radar. It's very difficult to get them working correctly. So, is the movie out here too?
Movie?
Movie. Did you copy the movie into it?
Yes.
Okay. Wherever it went to.
Is it I have
Separate
to
email.
separate email? Oh, okay.
Meanwhile, I had a question about your block diagram. You have an RS-232 control for your DDS.
That's
Is that to talk to your computer or to talk to the front panel?
No, it's to talk to a computer. Let's see, we can get back here far enough. Okay, here. This DDS VFO is actually, I bought it as a kit, who is N3ZI in Nevada. It was originally intended to be a substitute VFO for vacuum tube equipment. But he had an RS-232 interface on it that allows you to change some of the encoder parameters and some of the, like the IF offset and things like this, which is great. I mean, there's some issues with the DDS functionality that I wish I had, but they're not there, and I can't do anything about it. But the encoder, being able to change the encoder settings helped tremendously, because I'm using an optical encoder. Actually, these are sold out of China, and they're used on CNC machines. And it's got bearings on both ends. There's absolutely no play, laterally or back and forth of the shaft. It feels exactly like a high-end ICOM or YASIP. Now, when I bought mine, it was 360 pulses per revolution. So what that basically boils down to is if the DDS, if you're using a 1 hertz step, you will turn 360 hertz for 1 revolution. If you're on the 10 hertz step, it's 3.6 kilohertz, and it gets worse from there on. It's too fast. And I mean, if he hadn't made some of the encoder options available, the only option for me would have been to put a divider on both A phase and B phase of the encoder, divide down before it went into the DDS VFO. But what he did was, and it took him a while to find it, he said, this is a divide by X tick setting. The ticks were pulses. Divide by 2, divide by 3, all the way up to divide by 10. So what it allowed me to do was, you can divide the pulses from the encoder. So right now I have divided by 3, so it's 120 pulses per revolution to the DDS itself. Therefore, I've got for the 1 hertz step, 120 hertz revolution. On the 10 hertz step, 1.2 kilohertz. It's super good. Works real sharp. Now, I've got another encoder I recently purchased that was it's 200 pulses per revolution. You can buy them basically from 100 pulses all the way up to 600. But I just hooked this to the computer, and a simple terminal allows me to talk to the DDS chip and make the settings. It's really very rudimentary, but it's doable. So in other words, I had to use this to set the IF offset. You know, we talked about the IF amp. Initially, I had it set to 9 megahertz. But initially, I had it set to 9 megahertz, which was the theory at the time. See, that's what it's going to be 27 decibels down off the bandpass. So the ideal setting for the DDS VFO is for an IF's offset is 9000432. So you have to shift it depending upon what your crystal filter turns out to be. None of them are dead on. They're always shifted slightly. That allowed me to do that. And so worked out pretty good. And I have a little RS-232 connector on the side of the machine that I just plug it into. So I
some dirty movies here.
You just double click it, good work. Good. Good. Something small, what happened to it? Seems to be off to the side.
Oh, it's really.
It'll get bigger. There's some strange stuff here. Well, it's going to be kind of lock-eared there. Well, we can do that.
Okay, so again.
Let's go start at the beginning.
Right.
Okay. It's the receive operational. No RF amp. Putting the antenna through the bandpass filter right in the mixer. There. Muito aqui, volume beginner.
I'll try.
It should be a lot bigger. Should be really big.
This is maximum.
I want to do this.
Okay. Okay.
Let's see if we can go back to the start again. Wait, cut. Hopefully you can hear it. Right now it's on 10 hertz step. I'm playing with the DSP audio filter. And what I'm going to do is flip the CW and CW reverse. It should be centered so you get a single tone. Now you left turn up sideband, so you turn left, you go down tone. So it's going down. So that works perfect. It's pretty quiet. But could be two reasons. No gain. And down the RF chain. I'm going to wait until I get the RF amp working before I look into that. Anything I can hear on my IC7200, I can hear on this right now without an RF amp.
Oh, really?
You saw an F there. It's got an acceleration feature on the VFO, so you turn it faster and speed up. You wait a minute, it goes back to beat memory. Right now it's on one step, 1 hertz. No AGC yet, it's not. I haven't got it hooked up yet. I'm going to play with the filter, so you can get rid of a high tone. See, it's gone. You can clean it up, you kick it out altogether. The DSP has got 70 decibel skirts on it. The green LED is bandwidth, and there's another one, the orange LED is center frequency.
Do you have an RIT on this thing?
Nope. RIT is being used for transmit. You don't, to be honest, you don't need an RIT. I've never used RIT even on my 7200. The easiest thing to do, just push the split button, put both vehicles in the same place, and run split, and the same thing as RIT.
But if the guy tells you to call him up 1 or 2, what do you do?
It has a vehicle AB, and I can split.
You can split it, that's what I wanted to know.
Now, this is not going to be super viewable, maybe. I don't know how I should do this. That was made with a camera, and this is the first movie I've ever made. And the camera was propped up on a tissue box, so I was terribly at a loss on how to do it. And this is the first effort with this. I was holding the camera here, or holding this here. I kept getting cramps in my hand. So you'll see fluttering.
Wow.
Here's the bottom section. I'm going to pan around, you can see it. This is the bottom transmitter section I just got laid on the table. This is the receive block up on the top. This the other guy goes underneath. Let's swing over to the other side. Speaker's kind of in the way, but the DSP is here. This guy is slow as there. It was my hand. I couldn't hold it. Tuning rate's good. Feels real smooth.
Sounds good.
It sounds good so far, but the initial test just jammed the antenna into the mixer. So I know the gain is a little shallow. I mean, I can turn the audio up quite a ways, and it's not doesn't have the presence it should have. But this was a super thrill. It's been 2 years getting to this point. So this week, I actually heard something come out of it, and it's really encouraged me because you keep making these things and you never, there's no accomplishment. But this was a super boost.
Nice. You did a good job on it.
Yeah, it's a super boost to say, well, maybe I can get it done. I'm going to play with the filter. Turn it. 600 hertz filter, so the signals are pretty much 900 hertz to about 300. That's what you can hear. And it drops pretty fast. You don't hear a lot of high-pitched squealing or blowback to the filter. So it seems to be working better than I expected. So you can hear a definite peak when you hit the 600. Side tone is set for 650 hertz. You can hear a definite peak when you hit that. They're right there. Now, anyway, that's all the update.
Very good. I think it's quite an accomplishment.
Yeah, it's been educational and nothing else, I'll tell you that. And again, without
the fellow in Australia giving me help, we would have gotten this far.
So
It's,
you bought the whole kit from Hans?
no, this QCX, this is,
I'm not clear what.
well, this is the rig I've been building for 2 years. This is totally homebrew, with the exception of buying some kits here and there.
Oh, okay.
Hans QCX was kind of a sidetrack
Oh, I see.
that I took last December. And the reason was, before Hans went back to Turkey, he said he was going to make a QRP rig that is affordable. And I told him, if you make it, I'll buy it. So he made it, and released it in October, and I know he looks at all the PO numbers and the names, so I ordered one late November and got it December sometime and built it. But a lot of people, the LCD is mounted right on the board, and there's connectors on the sides, and it's a bear to put in the case. So I knew I wanted to put it in the case, so it was built that way initially, so that it would go in a case. Yeah, and that was kind of a sidetrack, and that was working. And interestingly enough, I belonged to another club in Chu, and when was it? March 31st. Chu City closed their culture center building. They've been used for 50 some odd years. And they're going to tear it down and make something else. So there was a big weekend event, Friday and Saturday, at the Chu Culture Center, where all the various people, bonsai, artwork, shoji, everything, was brought exhibits. And our club did a ham exhibit. And they had stations operational. And I took the little QRP rig, and I wasn't expecting too much, but we got a lot of interest. And it actually operated almost all of Saturday by at least 3 or 4 different operators, and they really liked it. And again, we made contacts all over the entire Japan with that thing. Of course, the antenna was on the top of the 7th floor. It was on the roof, but it was just a dipole. You know, it ran all day long. I had definitely run its ears off. Of course, I've got extra heat sinking internally, where on the regulators and on the PAs, where Hans didn't have any initially. I added extra heat sinking, but it's no problems, and it runs super good. But again, that was just a side issue, and I play with that in the evening sometimes. But this is the primary guy. But hearing the signals on it for the first time again was that.
But a thrill.
Yeah, it was a thrill, because you know, it's if you build something like the QCX rig, it took a couple of weeks to build, and it's no big deal. You start it, and you finish it, and put the power on, it runs. Long-term projects get very discouraging after the first year and a year and a half, because you know, if I was 30 years old, then I think I got plenty of time. But at 75, there ain't a lot of time left, so I got to get the sucker finished. So I'm still healthy, but working in a snail's pace here. But again, there's the RF amp, receiver RF amp it's got yet to be done. That's not a big project. The PA, a lot of SMD stuff, but that's the heat sink's already in place, and the board location set. All the timing for break-in, it's all complete. That was mine from ground zero, because there was no other circuit that I was satisfied with. Most rigs, including ACE and ICOM, if you run CW and you look at timing, you'll see the first dot truncate. It'll be shortened. And that's due to the fact that once you push the key down, it has to do all kinds of work to set up the receive transmit mode, get all the relays or anything else switched before the RF comes out. So invariably, the first dot will be truncated, sometimes 30–40%. And I don't know if you've ever noticed, sometimes when you hear, if you're operating code, you'll hear a J something, and you'll miss the first dot. It'll come out an O. And the reason is because his rig dropped that first dot. And that's, for a CW operator, that's a definite no-no. So
I didn't notice that.
now, on mine, what I did was, when I pushed the key down, the key signal actually goes through a pair of Schmidt triggers, the rise and fall time, and I slip the key, the entire character, I slip it by 15 milliseconds. So what comes out is identical to what goes in, except it's been delayed 15 milliseconds. Not shortened.
But in most of the modern rigs, there's an adjustment you can make to that, up to 30 milliseconds.
Yeah, but that's interesting. It's kind of a yes and no. But what are you shortening? If you shorten the dots or lengthen the dots,
nothing to
you
do with
lengthen them all.
It's as my understanding, that is to allow for any keying that's necessary before you put on the carrier.
Yeah, that's what they say. But I'll tell you what. ARRL runs reviews, technical reviews of a lot of rigs, and in their data, they will show you a graph of a 60 word per minute key up and down square wave and the actual RF coming out. And you look at it, even Elecraft has been shortened. Now there are some rigs, some flex rigs, that are pretty accurate.
Well, but most of the rigs that I've had all have this adjustment.
Yeah, well, it's
in 5 millisecond steps.
Yeah, but I think it's not what you think it is. I mean,
I don't know, but I mean, I've used it, and it's helped because it allows for TR switching time or other things. And also, there's another adjustment on the ICOMs that also decides how fast it ramps up as well.
Well, the rise time, fall time. And now, mine, because it's a Schmidt trigger, I've got pots on it to set the delay, and I use an integrator. It's I don't know if anybody's familiar with the call W7ZOI. He's an RF engineer that's now retired, has a lot of books out. Basically, mine runs 4 to 5 millisecond ramp up and ramp down time. Any more than that is too soft for DXing.
Well, I only noticed this feature on the ICOM, and you can go, as I remember, from I guess anywhere from 1 to 8 milliseconds.
My IC 7200 doesn't have that feature, unfortunately. I mean, it's a super cheapie, but 1 millisecond is too sharp. Especially, it's okay for DX, but if it's local, i.e. in Japan, you'll hear a very sharp thump thump. And that's the QCX, because it has the audio AGC, has a very similar sound. It's a little bit sharp on the leading edge because the AGC adjustment hasn't caught up with that leading edge. But 8 milliseconds is pretty soft.
Well, it hasn't stepped. You can do what you want.
Yeah, I mean, do what you want. I mean, I think an ideal one is somewhere around 4 to 5 milliseconds.
But I've only seen it on the ICOM. I haven't seen it on the other. It could be there, but I never saw.
To be honest, anything over 100 or 10,000 or 100,000 yens, I know I ballpark. I mean,
well, the ICOM is less than $1,000. The ICOM 7100 has that feature.
7,100.
Yes, it has that feature. In fact, now it's down to $760.
Must be a fire sale.
No, they're giving a special. You know, ICOM tends to drop their prices down this time.
Yeah, I know they do.
And HRO's got up to $760 now.
Well, the interesting thing is that 7200 that I have is that kind of squat, very chunky thing. They stopped production for a while, about 6 months, almost a year. And they restarted it up again, and it's selling in the States, but not locally. It's not being sold in Japan. But the thing was, it never was popular in Japan anyway. They always sold more overseas because everybody wanted a built-in antenna tuner. So the 7200, which is priced about the same as the ASO FT450D. It was about the same. The 450D had the antenna tuner in it,
Yeah.
and it always won. The buyer would buy that. But in reality, it's only 3-to-1 SWR adjustment anyway, so it's no big deal. I mean, it's okay, but. So, yeah, but anyway, I've been able to, through TTL, CMOS, high-speed CMOS, make the timing circuits all work very good, and I can set the delay time, the release time on the semi-break. I never use full break-in. I hate it.
Oh, you don't use full break-in.
No. So this rig is designed for what I do. It probably wouldn't suit someone else. Full break-in to me is distracting, especially if you're working DX, because the receiver background noise is coming up in between characters and has a tendency to drive me crazy. Now the relays I can stand. That's not the big issue. The receiver background noise is really this. Hans's QCX has full break-in or semi break-in.
Oh, I see.
It also has its built-in counter, built-in DVM, built-in RF wattmeter, so that you can adjust it without any extra test equipment. And it's got a keyer built in, but it's a little flaky. Biggest reason is that, as in most pieces of equipment, unless they separate the keyer from the primary CPU, keyer will never sound very good because there's too much work going on. So even though my 7200 has a built-in keyer, I use an external keyer all the time. The Logitech. Just one saying, I get the little brother to yours. You got the 5, I got the 4. Yeah, I always use that, and it's much better. So, any other questions? Island cutters, 40 years old. It's sure good if I had a drill press.
The islands that you cut on that one board, the crystals sit on top of there, or
They sit underneath.
Oh, underneath there.
So, in other words, let's see. It's a double-sided board,
Right.
and the crystals are underneath.
Oh.
The reason being is because I had to be able to get at all the capacitors where they were going to go.
Those blue things.
Yeah, those little blue guys. So the crystal legs are on islands. So then you can solder that, and they stay in place, and then you put your capacitors, and most of them are just series or to ground.
Right.
And there's no big problem. Underneath, it's all copper. So when you're finished, you solder the crystal cases to the board. So the crystal cases are grounded.
Oh, so the crystal is actually a piece of quartz in a box.
Exactly.
Okay.
In other words, ages ago, there used to be a what you call an FT243 crystal. It's all military crystal. We used to use them when we were novices. And if you open them up, they had 3 little screws, and you open them up, and there's a little square piece of crystal, quartz in there, held together against 2 plates. And you could fool with them, which I'm sure we did. But the newer ones, these HC6, are hermetically sealed cans, and the crystal's inside, and it's actually circular, and it's got something bonded to it. So the crystal's here and here, and then that comes out the legs, and the little case is soldered on. So you can't really go in and fool with it.
Right, right.
Now, these HC6 crystals come in 2 heights. There's one of them that's about this tall, and the 4mm type. Now, in reality, the taller type makes a better crystal filter, but it wouldn't fit.
Right.
So the 8 crystals that are in there are actually a matched set that I bought from a company in Australia, and they're matched within 3 hertz of 9 megahertz. So, but the reason that the center came off or slipped was because of the capacitor matching. It's, you know, there was.
They can't control the frequency when they cut them?
They do, but
Oh, they do.
there is a tolerance. I mean,
I have no idea.
well, now what I'm saying is, it depends on what you want to pay for. In other words, if you were in the military or government and you ordered those crystals plus or minus 0.0001%,
Right.
the crystal company could do it, but it would cost you an arm and a leg.
Oh,
The crystals that generally we can get a hold of are just probably made plus or minus 0.01% or something. Hundreds and thousands of them, and then they match them.
right.
If you ask for a match set,
Right.
then they are pre-matched. I bought off of eBay 9 megahertz crystals, a set of 20, just random. And I think I did characterize them, and they were plus or minus 50, 60 hertz back and forth around, you know. So, I mean, I can make a filter with them. They're doable, but it just may not be super good. But rather than buying 100 crystals and trying to match them myself,
Right.
I just bought 8 from a company in Australia that sells them pre-matched.
Pre-matched.
And they did the work. And they came out within 3 hertz, which just was totally blew me away. So that gives you a very good start. Otherwise, you have to fool around and try and match crystals, and you have to put numbers on them and make spreadsheets, and it's just a lot of nonsense. But yeah, so the crystals themselves, and that 2 layers thing, the bodies are here, the legs came up through the islands, they were soldered, and the caps added, and then lastly, shielding was put between the input and output to try and stop any leakage. And so far, it seems, for homemade, it seems to do pretty good. I don't have the test equipment to go test much further. I mean, I don't have any spectrum analyzers or things like that I can really look deep to see how, 70, 80 decibels down. I mean, the scope I got has an FFT function to it, so I can measure, for example, a low-pass filter or a filter, I can measure the second harmonic down to about 50 decibels. I can see that. The spec in Japan is 50 decibels, and I can actually see that. QCX is sitting at about 49 decibels on the second harmonic. Third harmonic is further. So it's almost there. Good enough.
Nobody will ever know.
Nobody will ever know. This should be about the one I'm building, because it's going through a bandpass filter and then a low pass filter, and it's been tuned before that. I should be able to get about 55 decibel suppression on the second harmonic or any spurious without too much trouble. Depends upon how the power amplifier operates. If it's going to be class AB, so it should be okay. The Hans's QCX is class E. Class E, and he's running it runs at about 85, 90% efficiency. Very strange. So I'm surprised he's doing as good as he does. Class E basically means you're driving it on, the PA's on and off with a square wave. With a square wave. No sine wave. You're putting the square wave in there, and you're bouncing here and bouncing there, and you're letting the low pass filters do all the work. There's no pre-work at all. They're getting a square wave in there. But it's very, very efficient as compared to a Class C or AB or Class A operation. So
he gets his efficiency by going to E, and then he cleans it up with the rest.
Yeah, and the filters that he's gone through a couple of iterations of those filters too, because the filters are also used in his Whisper kit at WSPR, and the ARRL bought one of his Whisper kits, and they did the technical review on it, and there was only about 35 decibels of suppression. So they came back and gave Hans a bad time, and he went through some real misery trying to fix it. Well, it turns out that it was not necessarily the filters per se, but it was long leads on his board, switching board, etc. I mean, there was some other issues, but The filters themselves, sitting right on the adjacent to the PAs, works pretty good. They're pretty sharp. So, and they're 7-order filters, 3 coils, and a full range of capacitance. So, a lot of times you'll see guys using 5-order, 2 coils, and associated capacitors, and that's not going to get you much below 30 decibels, 35. It's just not good enough. 7 orders at least, and seems to work okay.
Mhm.
So, I did Manhattan style. This is a real effort because I got to get a magnifying glass out to see this kind of stuff.
Now I guess so.
But it's super good for RF because you have with the perf board, that's good audio, okay. But if you make a mistake, you're forever trying to flip it over and look to see where your solder connections are and where the components are, and it's really a bear to troubleshoot. With Manhattan style, everything's staring you in the face. You can see where everything is, and if you have to change a part, you just pop it off. Whereas the perfs board, invariably, leads have been curled over, bent over, and you pull it out, and the stupid pad comes off with it, and there's all kinds of grief. But this is pretty good. It's slow, but it's good. Anyway, I'm tired. Very lucky. And Hans, I hope you saw this. And Lou, I know you're going to see the copy too, so.
Okay, so there are the other 2 agendas today. One is Hamware I discussed with Ari, our president. The last, maybe you remember the last year, there were mostly no content on TIARA booth. We couldn't show anything to our audience. So if we will not have contents also in this year. Ari and idea of Ari and me is gave up to a book TIARA booth. The last year only a meeting point after the TIARA booth. Last year, if someone have idea and someone manage all over the TIARA booth, I'm happy to book TIARA booth only for this year. This is the first topic. If you have another idea, please let me know via the email or something. If we have a value to book TIARA booth, I will discuss with Ali. Anyway, cost is $180 for our booth. 18000円。18000円ぐらい。
ゴミ売れないやつです。
The second is a meeting, a TIARA meeting. The next month is here, 3rd Friday here. But the monthly meeting in June is my idea is social. Social means go to a bar or somewhere and kind of a party. Bak-san introduced a very nice bar in Roppongi long time ago.
I think so.
So my idea is go to that bar in Roppongi for the June meeting.
If you don't mind.
Our president Ali maybe understand, but a little bit misunderstand. And his idea is go to Mount Fuji in June. Mount Fuji. It's another social meeting. He said if someone is interested in the go to Mount Fuji and go home 5th grade, maybe by car on the weekend please let me know. I will discuss with us.
Well, actually, around, this was, I think, around 1995, we actually did field day on the fifth station.
Or on the top.
And some went to the, you went to the
Some
top,
went to the
yes,
top.
yes. At night. Yes, I remember you.
You went to a top.
Jim, you, Jim, and two or three others, right?